Hello, and thanks for clicking on this Prenorgulus production. Today, we're going to be talking about how to solve log equations. Equations that have logarithms in them. Logarithms are natural logs. Okay, they include a logarithm or a natural log from the start, from the beginning of the problem. All right, so we're going to combine a bunch of things that we've already learned in this chapter, okay, and work with log equations. All right, so let's get started. Here we go. So, log equations. Couple of things that you need to know or need to remember. The argument of a log function must be positive. It cannot be negative. All right. Solving equations that involve logs, when we get to it, can bring up extraneous solutions. Extraneous solutions, you've seen them before, maybe in Algebra 2 or in previous classes. They're solutions that appear when solving the equation but do not work when you check them in the original problem. Okay? When you solve equations that involve a logarithm, you must check your solutions in the original equation to make sure that the argument of the log will be positive. Okay? If that solution would be used in the original equation. If you get any of the logs that end up with a negative argument when you check that answer, then the solution is extraneous and you have to throw it out. It does not give a correct answer. Okay, it doesn't make the equation true. All right, we're going to see that. So we're going to have to check each time. So for log equations, not only do you have to solve, you actually have to check. Okay, because some of the answers could be extraneous. All right, so we're going to solve two types of log equations here. All right, so the first type we're going to solve is equations that involve one logarithm. Okay. If an equation involves one logarithm, we're going to isolate the log in its argument, and then we're going to switch to exponential because we can't do anything with it in log form. But if we switch to exponential, we'll be able to work with it. Okay? But we have to isolate the log first. So, letter A, I'm asking you to solve 2 times the log of x plus 3 base 3 plus 4 equals 10. Note, x plus 3 is the argument of this log. The plus 4 is not inside the argument. So I want to isolate that. I want to get that by itself. Okay, consider that like your variable x. All right, so if that was my variable x, how would I solve this equation? Well, I'd subtract 4. Gives me 2 log of x plus 3 base 3 equals 6. Then I'd divide by 2. And I'd have log of x plus 3 base 3 equals 3. A lot of 3's running around, not on purpose. Okay, now I have my log and argument. They are now isolated. They're on one side. I got another number on the other. And I can't do anything with this. I don't know how to do this. But when you don't know how to do something in one form, you switch it to the other. So I'm going to take this and switch it to the other form. That would give me 3. 3 becomes the base. And these two switch positions. 3 to the third equals x plus 3. So that gives me 27 equals x plus 3. I subtract 3 on both sides. I get x equals 24. So 24 looks like my answer. I have to check. Okay, you have to check. Here we go. So all I'm going to do to check is I'm going to take 24, put it in up here. 24 plus 3 that's 27 in that argument. That's a positive number. So then this answer checks, and 24 is the correct answer. I'm all done. Okay? That's what I mean by check. You don't have to check the entire thing. Just the argument of each of the logs to make sure that the argument comes out to be a positive value. All right, let's try a couple more here. Same idea. Okay? We're working with one log right now. We're going to try to isolate this log here with its argument. Remember, treat that as like your x. So we're going to subtract 2 on both sides. We're going to have log of 2x minus 1 base 5 equals 2. Okay. Now, my log is isolated, so I'm going to switch the form. I get 5 to the second equals 2x minus 1. 25 equals 2x minus 1. Here we go. We're going to solve for x. We add 1. 26 is 2x. And divide by 2. 13. Looks like 13 is the answer. Okay, we got to check. Come on up here. 2 times 13 minus 1 in the argument. That's 26. 25. That's good. It's positive. So then this answer checks, and it's the correct answer, 13. All done. All right, letter C, we have the natural log of 2 minus x over 5 equals 1. So again, we're treating this as my variable. Okay, so I'd multiply by 5 to isolate the natural log of 2 minus x equals 5. Let's erase that there. Start again. Now, I want to switch the form on this. Log is a fancy, or natural log is a fancy way to say log with base e. Switch the form. So e to the 5th equals 2 minus x. I'm going to try to solve for x. So let's see. I'm going to subtract the 2 over. E to the 5th minus 2 equals negative x. Divide everybody by negative 1. X is equal to negative e to the 5th plus 2. Okay. All right, now I got to check it. So that's ln 2 minus negative e to the 5th plus 2. I got to make sure this thing's a positive. I'm going to distribute the negative. Gives me natural log 2 plus e to the 5th minus 2. 2 minus 2 is 0. It gives me ln e to the 5th. So e to the 5th, that's a positive number, 2.718, right, to the 5th power. That's positive. So then this answer checks. It's a good answer, and we'll take it. Okay? Solving equations, log equations with one log expression. Now, what if there are multiple logs? When there are multiple logs, what we're going to do is we're going to try to reduce the equation to look like one of the two following forms. Either we're going to have all of our logs isolated on one side and then a number on the other, or we're going to end up with logs on both sides, but we can only have one logarithm on each side. Okay? One logarithm on each side. So, if the equation we get looks like this form, well, that's what we just did. We switch to exponential and we go solve it. One log. If we end up with logs on both sides, then the arguments of the logs have to be equal and we can solve it. All right? To get equations in one of these two forms, we can use the log properties that we learned to help us. Okay? We're going to be condensing logs, going from right to left, making them smaller so that we can work with them. Okay? All right, so these are our log properties. Don't forget, log of a times b. Well, really, we're going to be going from right to left. So log of a plus log of b. If you have two logs that are added, you can put them in the same log by multiplication. If you have two logs that are subtracted, you can put them in the same log by division. If you have a number in front of a log, you can take that number, stick it up on top of the power, and use that property as well. Okay, so here we go. Remember, don't forget, we could have extraneous solutions. We got to check. All right, let's take a look at letter A. We have log of x plus 2 base 5 plus log of 4 base 5 equals 3. On the left-hand side, we have two logs that are added. We know that if we have two logs that are added, we can put them together in one log by multiplication. So that's what we're going to do. We're going to write log base 5. We're going to write 4 times x plus 2. We can distribute that 4. It's going to equal 3. So that's log of 4x plus 8 base 5 equals 3. So now we end up with a log on the left side, no log on the right side. So we have one log. It's isolated. So now we're going to switch the form. 5 to the third equals 4x plus 8. So 125 equals 4x plus 8. 4x equals 117, subtract 8, right? And then x is 117 over 4. Okay? Now, don't forget, you got to check. 117 over 4 plus 2 Well, I don't know what number it is, but I sure know it's positive. That's all I care about. And then this 4, there's no x to put in here. That's a positive. So then this answer checks. It is the correct answer. Okay, let's try letter B. Natural log of x minus natural log of 5 equals 2. Same thing. I have on the left-hand side now, I have 2 natural logs that are subtracted. If I have 2 natural logs that are subtracted, I can put them together by division in the same natural log. So that's going to give me the natural log of x over 5 equals 2. Now I've turned my 2 natural logs into 1. I now have 1 natural log on the left, no natural logs on the right. So I'm going to switch the form. So natural log is just a fancy way to write log with base e. There it is. Switch the form. E to the second equals x over 5. And now, multiply by 5 on both sides. You get 5 e to the second equals x. You got to check that. Okay, take 5 e to the second, put it in there for x. Well, that's certainly a positive number. E is 2.7 squared times 5. That's definitely positive. And then 5, well, there's no x there. So that's it for that. And that's the right answer. Okay, let's try to make them a little more complicated. Log of 3 plus log of x plus 4 equals log of 5x plus 6, or 5x minus 6. Very creative in the numbering. Okay, on the left-hand side, I have 2 logs that are added. I can put them together in 1 log with multiplication. There we go. The right-hand side only has 1 log on it. That's good. So I'll distribute the 3x, or the 3 log 5x minus 6. Now I have logs on both sides. There's 1 log on the left, 1 log on the right. Then the only way these two things will be equal, if you have log of x equals log of y, then x has to equal y. So the 2 arguments have to be equal to each other. So 3x plus 12 has to equal 5x minus 6. And now I'm going to solve this for x. I'm going to move the 5x to the left. I'll move the 12 to the right. Negative 2x equals negative 18. Divide both sides by negative 2. I get x equals 9. I got to check it. 3, no x, that's positive. 9 plus 4, that's positive. 5 times 9 minus 6, that's definitely positive. This is a good answer. It's the correct one. Okay, not extraneous. All right, let's come over here. Same idea. Natural log of x plus 1 minus natural log of 4x plus 2 equals natural log of 7. I have 2 natural logs that are subtracted. So I can put them together in 1 natural log by dividing them. Now I have 1 natural log on the left, 1 natural log on the right, which means the arguments have to be equal. Can drop the logs. Now I got to solve this for x. So I got to get the 4x plus 2 out of the denominator there. So I'm going to multiply it on both sides. That clears that out, and I can distribute that. So I have x plus 1 equals 28x plus 14. I'm going to subtract 28x on both sides. Subtract 1 over there. Negative 27x equals 13. And divide both sides by negative 27. I have x equals negative 13 over 27. Okay, now I got to check this. I don't care that the answer is negative. What I care is if I take this negative answer and plug it into this argument, will the argument still be positive? So, negative 13 over 27, if I'm just trying to get an idea, obviously you can type it into a calculator. Negative 13 over 26 would reduce to negative 1/2. Okay, so this is a little bit smaller than negative 1/2, just so that I have an idea. A little bit smaller than negative 1/2. So if I were to take, let's see, something negative 1/2, let's say, and add 1, well, that's going to be positive. So that's okay. This is the one that's more interesting. 4x plus 2. If I were to take negative a half and put it in, I actually get 0, which makes no sense. You can't have the natural log of 0. But this is not negative 1/2. It's just a little bit smaller than negative 1/2. Okay? Just a little bit smaller. So take something just a little bit smaller than negative 1/2, multiply it by 4, you get something just smaller than 2. Maybe negative 1.9 something. I don't know. And you add 2, that's still a positive number. Barely. So this is a good answer. On the right-hand side, you just have ln7. There's no x to put in there. That's a positive. So this does work. Barely. All right, 2 more. Same idea. We have natural log of x plus 3 log 2 equals log of 2x minus 7. On the left, first thing I can do is take this 3, make it a power. So I have log of x plus log of 2 cubed equals log of 2x minus 7. Now I have 2 logs on the left that are added. I can put them in the same argument by multiplying. 2 to the third, that's an 8. So that's going to be log of 8x equals log of 2x minus 7. So now I have a log on the left, a log on the right, just one of each. So the arguments must be equal. 8x must equal 2x minus 7. I'm going to subtract 2x on both sides. Here's 6x equals negative 7 and divide by 6. X equals negative 7 over 6. All right, I got to check that. If I put negative 7 over 6 in the first log, it's just x. Whoa, that's the log of a negative 7 over 6. That's no good. This answer then is now no good. I don't have to keep checking. I found one log where it doesn't work. So this answer is no good. There are no answers left. So this has no solution. Okay, this answer is extraneous. There's no answers remaining for me to check. So it has no solution. All right, and finally, letter F. Log of x plus 2 base 3 plus log of x minus 3 base 3 equals log of 14 base 3. Okay, on the left, I have 2 logs that are added, so I can put them in the same log by multiplication. Log of 14 base 3. I could FOIL the inside here just to make my life a little bit easier. That would give me log with base 3, x squared minus 3x plus 2x minus 6 equals log of 14 base 3. So that's log of x squared minus x minus 6 base 3 equals log of 14 base 3. So now I have a log on the left, one log on the right. So the arguments must equal each other. And now I have a quadratic. It's got an x squared in it. How do we solve quadratics? We move everything to the same side. And then we go and factor it. X and x minus 5 plus 4 equals 0. Split them. We get x equals 5. We get x equals negative 4. Now I got to check them. Got to check them both individually. If I take 5 and put it in, 5 and 2 makes 7. That's fine. 5 minus 3 makes 2. That's fine. 14, that's going to be fine no matter what. If I take negative 4 and put it in, negative 4 plus 2, that's negative 2. That's no good. That's not allowed. Can't have the log of a negative. So that answer is extraneous. So I threw one answer out. One answer I accept. I accept that x equals 5 as a valid answer. There's one answer. I got one of the two to be considered a correct answer. The other is extraneous. And that's it. That's all there is to this. Okay? There's a lot of steps. There's a lot of remembering some things you did before. And then for the log equations, the biggest thing is you got to remember to check your answers and make sure that they're valid. Otherwise, you're going to be giving me an answer that really shouldn't be an answer. Okay? And as always, thanks for clicking.